Welcome to Module 203B on Temperature Sensing and Control Devices. The most important interface I have in my heating and cooling system is my thermostat, and my thermostat does multiple different jobs. It improves my comfort and economy, it will test my air temperature, and it will automate my turning on and off of my heating and my cooling. When the air differs too much from the set point inside the thermostat, it will activate the system. Inside the thermostat, we have three different types of contacts that we can use in order to open and close our switches. The first type is a mercury contact, which contains a small mercury vial with two leads mounted on a bimetal coil. As the temperature changes, the mercury vial will tip, and when the mercury tips, it makes or breaks contact between the wires. These are not suitable for high current ratings, and since mercury is a toxic metal, these are not in production anymore. The second type of contacts that we have are called spring-activated snap action contacts, and they are exposed contacts mounted on a bimetal strip, and they're open and closed with spring force. That force cleans the dirt from the contacts when closing and prevents arcing when opening. The closing contacts also have a wiping action to help with the cleaning. Even including that, they are still a higher maintenance device than we see with the mercury contacts, but they are more suitable for higher current loads. The third type of contact arrangement we have is called the glass enclosed magnet and armature contacts. The contacts are inside a glass tube, which helps for cleanliness. An inert gas inside the tube also prevents any arcing so that we have less maintenance. A magnet on a bimetal strip will attract the magnet inside the armature, which will close or open the contacts. The type of contacts that we have inside our thermostats will change for our application. For our heating stat, we have a normally closed device. It contains closed contacts when cool, which means when the temperature drops, the contacts will close, and that will start the gas valve. When the temperature rises to a set point, the contacts will open, stopping the gas valve from firing. Then the room cools and the cycle starts over again. So my heating thermostat is shown with no heat in the system, which means I want the system to operate. Therefore, it must be a normally closed switch. For my cooling thermostat, I want the opposite to happen. My cooling thermostat is a normally open device, which means that contacts will open when it is cool. When the room heats up too much, the contacts will then close, starting the cooling unit. As the cooling unit runs and drops the temperature inside the house, then the contacts will open again when the temperature drops, stopping the cooling unit from operating. We can also have a dual function device that would have both these types of thermostat built into the same unit. This is considered to be a heating and a cooling stat. There will be a selector switch which chooses between the heat or cool mode, and some electronic models have a heat-cool selection. You must make sure that the heating settings and the cooling settings don't overlap, otherwise you're going to have heating and cooling cycling happen. When you're wiring a dual-function heat-cool stat, you must make sure that the wiring patterns on the thermostat itself match the same wiring designations on the furnace. A problem that we can have with thermostats is by the time that they have sensed that a condition has occurred that they need to correct, to the time that we feel the correction inside the room, whether that is heating the room or cooling the room, by the time that action happens, we're actually outside of our comfort zone. In order to accommodate this, the thermostats have something that's called an anticipator. The job of the anticipators is to activate the thermostat functions a little early. In the heating thermostat, the anticipator is wired in series with the gas valve, and its object is to turn the heat off just a little bit early. When the contacts inside the thermostat close, it energizes the gas valve, which also in turn energizes the anticipator. The anticipator then produces a little bit of heat. The thermostat now senses not only the room temperature, but also the anticipator temperature, and that results in turning off the burner at a lower temperature than what the preset is. Keep in mind, when the burner shuts off, there's still heat inside the plenum, and the furnace fan is still pushing all that heat into the room. The result is the room warms up to a nice, comfortable temperature instead of becoming too hot. The anticipator in a heating set is adjustable, so we can change the current flow to fine-tune exactly when the thermostat turns off. The anticipator that's inside the cooling thermostat is somewhat different. This anticipator is now wired in parallel to the contacts, and the object is to start the air conditioner early. While the thermostat contacts are open, the current runs through the anticipator. However, the anticipator has a high enough resistance so the cooling relay doesn't engage. The anticipator will add to the room heat to start the cooling coil early. When the contacts close, the anticipator is bypassed and doesn't produce any more heat. When the cooling coil shuts down and the room is cool enough, the anticipator will once again be engaged. These anticipators are not generally adjustable and they're all factory preset. Both types of anticipators are designed to prevent rooms from being too hot. A very popular option in today's market is a programmable thermostat, and this not only helps with comfort, but economy. We can set up a schedule inside this type of thermostat in order to adjust the temperature settings automatically throughout the day. This will result in a lower temperature during the day when nobody's home, and a higher temperature at night when somebody is home. This way you can realize energy savings by not having to run your furnace while the house is empty. Some large commercial buildings will require a multi-stage heating system. This is a two-stage system that has 2 burners and 1 thermostat. The stat has 2 different sets of contacts, 1 for each burner, so it would be a 3-wire thermostat. Stage 1 produces low heat and low speed fans and will activate within 0.4 degrees of the set point value. This way we can heat up small areas of the building at once, and it's meant for low demand. Stage 2 will produce high heat and high speed fans, and it activates within 2 degrees of the set point value. This is when people first enter the building, they crank up the thermostat. Stage 2 will ignite, igniting both the heating units, and once we get close enough to the room temperature, Stage 2 drops out, leaving Stage 1 still ignited. Stage 1 is always the first one on and the last one off, and this improves efficiency as well as maintains comfort level better. When it comes to identifying the best place to put a thermostat, we have to consult a list of do's and don'ts. For example, we do not want to put it on an outside wall because the temperature of the wall will produce false readings. We also do not want to put it anywhere between any hot air vents or return air vents because then the airflow past those vents will also create a false reading. We do not want it in an area with no air movement, such as closets and bedrooms. We do not want it near any heat sources, such as lamps, fireplaces, or direct sunlight. Typically, we want to choose a central location that everyone can access and no one has to go into any private areas. The type of switch we have also makes a difference in the installation, such as Mercury switches must be level when they are installed. And also the thermostat itself must match the system in which it's being installed to. So if I have a 24-volt thermostat, I must make sure that's going to be operating on a 24-volt control circuit. 120-volt control circuit means 120-volt thermostat. You've now reached the end of 203B. Go back to Blackboard and do the knowledge check, and then you can continue on to 203C.